Hello and welcome back to Health Unlocked, the Power of Salutogenesis with Jasen Petersen. Jasen, how are you?
I'm doing pretty good. We were talking about weather last time. It snowed a little bit here, but I think it's supposed to get up into the 60s today here, which is pretty warm.
We are lucky today. It's already in 60s. So we'll take it. It's getting better. Hopefully now we will have a real spring started instead of snow. But I'm more interested in today's topic than the weather. It is all about a little bit we touched in our previous episodes. IBAL, IBAL, that's the product, and we call it IBAL. And we're going to go deeper into understanding it a bit. But first, this is kind of like a build-up from the previous episode that we discussed. So if you're ready, let's go. All right. So last time we explored cell suppression theory by Mark Lintern and its implications for cancers. The dominant cancer treatment paradigm assumes that mutations drive cancer, but we discussed there is a strong evidence suggesting that fungi and immune suppression play a major role. So do current conventional treatments like chemo, radiation, and immunotherapy even address that at all? What do you have to say on that?
So for decades, you're right. The dominant belief has been that cancer is a genetic disease and that random mutations are causing this uncontrolled cell growth. And that assumption led to it's very complex, but it's a simple treatment strategy, which is kill the cells before they kill you. And chemo, radiation, and even immunotherapy are all kind of designed with this in mind, right? So they attack the tumor, and based on the idea that if we eliminate the cancer cells, the problem's solved, and it's gone. That really is that whole approach ignores the bigger picture. If mutations were the full story, we wouldn't see cancer cells behaving cooperatively and forming these structured tumors or creating microenvironments that actively suppress function. So there's got to be more going on here. And the terrain that allowed cancer to grow in the first place is still present, even if you kill what's there. And that's why cancer treatments often fail, right? So chemo and radiation, those treatments don't just kill cancer cells. They kind of kill everything in their path. And that's why patients experience, hair loss and nausea and immune suppression and organ damage. And what can kind of be even worse is that even if they kill most of a tumor, if there's any or just a few cancer stem cells or the CSCs that survive, then the cancer can actually come back more aggressive than before. And as we now know, chemo and radiation can actually stimulate the CSC production. Remember, we talked about stem cells get produced whenever there's a large die-off of cells. Well, cancer cells do the same thing. So stimulating the CSC production or cancer stem cell production can actually lead to relapses in the future. And in some cases, chemo or radiation can actually directly cause new cancers by furthering immune suppression. Let's see. So immunotherapy. So immunotherapy was marketed kind of as, the big next leap, a way to train the immune system to target cancer instead of poisoning the body. And that sounds great. The problem is that I guess it only works in a small subset of patients, and it doesn't fix the local immune suppression, which is that's the actual reason that cancer develops and can persist in the first place, as we've discussed with the cell suppression theory. And I guess the other issue with immunotherapy is by the time that someone has cancer, their immune system is already suppressed or in a dysfunctional state. And instead of fixing that suppression, immunotherapy just tries to kind of force this attack. But if the immune system is already exhausted, how effective can that really be? Now, in some cases, it's a different side of the immune system. So you still kind of run into issues there. But so let's, you didn't mention it, but let's actually take like checkpoint inhibitors as an example. So the idea is that they remove kind of immune suppression breaks. So, but if the immune system is still dysfunctional, just taking the brakes off doesn't necessarily solve the problem. And that's why immunotherapy often leads to, autoimmune side effects, right? You've got coitus, thyroid dysfunction, and even kind of life-threatening cytokine storms. You've got immunotherapy like the CAR T therapy that actually takes things even a little bit further, genetically modifying immune cells to attack tumors. And all that kind of sounds cool, but if the terrain is still suppressing immune function, especially local immune function, then cells, they won't survive long term. And that's kind of why the CAR T therapy is toxic. It's also expensive, and it doesn't work for many cancers. So I guess the result of all of these conventional problems, I suppose, is despite decades of research and billions of dollars, survival rates for most late-stage cancers really haven't improved. Patients go through multiple rounds of toxic treatments, and while some experience remission, very few achieve lasting cures. You're not even allowed to say cure cancer, right? So when you've cured cancer, you're only allowed to say it's in remission, and then you're in remission for the rest of your life. Well, after you die of old age, can we look back and say, well, we must have cured that cancer? I mean, it's still a little weird, but cancer continues to be treated like an enemy that needs to be destroyed instead of a terrain dysfunction that needs to be corrected. And I mean, really, if the current approach worked, we wouldn't still be seeing millions of deaths every year. And so all of this kind of, the real question is, are we targeting the wrong thing? We now know, I guess, or at least some of us know, that fungi and localized immune suppression play a major role in cancer development, yet no conventional treatments are addressing that. So you're right. No is the answer. No conventional treatments are addressing it.
Yeah. So obviously this was more around the conventional treatments, but what about the newer therapies? Like there are things like histotripsy, cell reversion therapy, and then there are, off-label repurposed drugs like Ivermectin. And so are these real progress, or at least heading in the right direction with those, or are we still wrong target, same problem?
Well, okay. So it is encouraging to see these new approaches being developed. And many of the therapies do kind of represent incremental progress, I suppose. But you kind of got the right question there. It is, are we still operating under the same flawed paradigm? And for the most part, we are, right? So the majority of these newer therapies are still focused on killing cancer by any means necessary, rather than restoring the terrain so that cancer can't thrive in the first place. It's still a pathogenic, we know better mindset than a salutogenic body knows better approach, right? So go through a couple of what you mentioned. Histotripsy is an ultrasound therapy that destroys tumors with highly focused sound waves. And it's an improvement over chemo and radiation because it avoids systemic toxicity. It doesn't cause nearly as much damage to surrounding tissue. But at its core, it's just a better way to kill cancer cells. It doesn't address the immune suppression that, PRM or the tissue resident macrophage fatigue or fungal involvement. Those are the things that allowed the cancer to take hold in the first place. Doesn't address those at all. Now, that being said, the histotripsy doesn't create the same collateral damage that chemo does, so it's not nearly as harmful. And it might not stimulate as much cancer stem cell production either, but it's still really just cleaning up a symptom rather than correcting the environment that allowed cancer to develop in the first place. The reversion therapies, that's actually a really interesting idea, at least the way that it's being presented in the media at the moment. The idea is that instead of killing cells, they're trying to reprogram them into normal functional cells by modifying their gene expression. That's a big shift away from the mutation-focused oncology, for sure. And at first glance, that seems like a huge breakthrough. But when you really examine it, it still operates under a cratogenic framework. It's actually forcing cells into a new state rather than restoring the conditions that allow them to naturally recover and then self-terminate. This means that it ignores the real root causes of the cancer, right? The immune suppression, the persistent microbial stress, and mitochondrial stress and microbial involvement. But so here's the problem. Forcing differentiation doesn't mean restoring function. So cells don't exist in isolation. They respond to their microenvironment, the immune signals, and different metabolic states, right? So if this brain is still supporting or suppressing, the immune function, simply pushing them into a different lineage doesn't fix the core issue, right? And so I guess that so you're not following, and you're not. It's completely disconnected from the cell danger response, right? So the natural progression of healing, you're forcing the cells to do things or not do things in the wrong states. That can cause all sorts of other issues, right? So, I guess another big concern of mine with that is that these, the reverted cells, put little finger quotes around that, they still have DNA damage, right? Due to the oxidative exposure that they occurred while being cancerous or in the process of becoming cancerous. And the, at least the study synopsis that I read regarding the cell reversion therapy doesn't address this at all. And just because the cell is no longer cancerous, meaning it's no longer replicating, doesn't mean that it's healthy. And if these cells were actually fully functional after being reverted, the ones that still have DNA damage should naturally undergo apoptosis, but they're not. And if they don't, something's wrong. Now, I guess understandably, this is early stage in their research, right? But there's no mention of apoptosis occurring, which suggests to me that they might be disregarding the CDR entirely, essentially forcing cells into an artificial phase that rather than allowing them to progress naturally. And I don't know, without proper immune and metabolic coordination, right? So the coordination is gone. Without this coordination, the therapy could leave behind dysfunctional but non-proliferative cells, which may still contribute to long-term tissue dysfunction and inflammation and all sorts of other things. I guess the big question would be, how are they going to ensure that the cancer cells, or that only the cancer cells would lose replication function, right? Because I don't know how they're really supplying the drug or whatever they're doing, but likely that is a systemic first thing as well. So rather than get too far into that, I apologize if I got too deep into addressing it. Reversion therapy is definitely a step in the right direction. I like that it's not focused on genetic mutations anymore. but it still doesn't address the root cause or the root causes of cancer. And as we kind of know now, if you're not resolving the fungal or the microbial suppression, the immune fatigue, microbial stress, you're just kind of overriding the body's response rather than restoring its ability to regulate itself. And that's where we need to think bigger, not just about forcing cells to behave differently, but about removing the blocks that prevent them from naturally healing or self-terminating. Let's see. You also mentioned off-label drugs like Ivermectin. And I apologize. This is getting to be a long answer. So yes, researchers are exploring off-label drugs like Ivermectin and a bunch of others. And while some of these drugs may offer real benefits, their mechanisms do vary a lot. Let's break them down into, I guess, 3 categories. The first category isn't really a drug, but let's talk about, nutritional supplementation. So that would, instead of being a cratogenic approach, that's more of a salutogenic approach. And I like that. Let's just take a couple quick examples. You've got curcumin, that modulates oxidative stress and inflammation, by affecting different pathways. And then you've got like, EGCG, basically a green tea extract, and that can block other cancer promoting pathways, while supporting immune and metabolic balance, I suppose. And again, because they work by enhancing normal biological functions and processes, rather than forcing things, I guess I'd say I like that better, but that's still a systemic approach for a local problem. So while I'll say that's good, it's going to many times have lots of issues actually getting to where it's needed. I guess the next step would be, really the antifungal off-label drugs, right? So the various repurposed drugs, are most likely useful because they are, they target fungal involvement. And remember, that's a factor that's still ignored by most. And as long as their, cratogenic actions, whatever those might be, are kind of minimal or benign, they can still be helpful, particularly in the short term. And you mentioned ivermectin. So ivermectin, it has antifungal properties. And so it targets the glutamate gated, chloride channels. And that disrupts neuromuscular function in parasites. And, that sounds really scary, but mammals don't have these, channels, in which case it doesn't really affect us. It only affects parasites. So in that case, it's safe. Now, ivermectin also modifies GABA receptor activity, which humans do have, but it's generally in our brains, and ivermectin doesn't cross the blood-brain barrier, which might mean that it's less effective for brain cancers, unless the brain barrier has been compromised. And actually, thinking about that, brain cancers almost always occur with a compromised blood-brain barrier. And if you think about that, that actually supports, or that's evidence to support the CST framework, because how would the fungi get in there if it can't pass through the blood-brain barrier? Boy, that's hard to say many times. So since the brain cancers don't really ever occur without compromising the blood-brain barrier, that makes sense, because that was the pathway for the fungi to get in there in the first place. So maybe ivermectin can actually help with brain cancer. I'll take that back. Although I don't know what the side effects might be for it to start affecting the GABA receptors in the brain. So I guess I'd talk to somebody who really knows what they're doing with that before trying that. But there are all sorts of other antifungal drugs. In many cases, as we kind of discussed before, they're trying to make up all sorts of different reasons that it works, but they also happen to be antifungal, and maybe that's the real reason that they're working. Again, as long as their cratogenic actions aren't too problematic, they're probably fine, especially in the short term. And then I guess the third thing to mention would be more problematic cratogenic drugs. So like a doxycycline or doxycycline, I don't really know how to pronounce that, works by interfering with the cancer cell's mitochondrial function, and other metabolic pathways. And that's supposed to weaken cancer cells, but it also kind of raises concerns about broader unintended effects on the systemic cellular health. So let me try and wrap that up. So all of these things kind of do represent an improvement over, I guess, more conventional treatments now, because they're either more targeted, less toxic, and some of them are working with the body instead of against the body. But systemic killing still causes more problems than it solves. And I guess I would take these or break these cancer treatment strategies into 4 basic categories, right? One is the systemic killing, and that's like chemotherapy. Those would be the worst. Local killing, that's better. That's like the histotripsy. Then you've got systemic support, which is getting better. And that's more of the nutritional things that we talked about. And then local support, which I would say would be the best. Local immune restoration, removing the fungal suppression, restoring oxidative balance, and kind of reactivating that local immune function. And if you combine local support, systemic support, and even local killing, but only when that's needed, you could kind of have the absolute best approach. But I still think that systemic killing is the worst of all.
And now, in all this, where does this lead us to? Like, where does now IBAL comes into picture here? Can you also tell us a little bit, for our listeners who probably missed our previous episodes, what IBAL is and how it works?
Sure. Okay. So, again, up to this point, we've been talking about how conventional cancer treatments and even some newer therapies are still operating under a cryogenic kill the cancer mindset. And the focus is always on forcing the body into a certain state, whether that's killing cells or trying to reprogram them, or I guess forcing the immune system to attack harder. But the real question kind of comes from, why are the cells cancerous in the first place? And why are they staying in that survival mode, or the CDR2, the second phase of the cell danger response, instead of moving forward into healing or self-termination? And we identified much of this in the previous episode, so I won't kind of get into all of that again. But let me introduce a new term here. It's cellular and microimmune optimization therapy, C-MO. We pronounce that CMO. Instead of forcing changes, it's about removing the barriers that are preventing normal recovery. And this is definitely a terrain-first approach that restores the local environment. So cells have what they need to either heal properly or self-terminate if they're too damaged, right? So there are 4 main principles. The first is eliminating microbial involvement or suppression. And we now know that fungi play a major role in cancer, actively suppressing the local immune system and keeping cells trapped in that proliferative healing stage. Restoring oxidative balance. So we have to remember, oxidative stress isn't just damage. It's a key signaling mechanism, right? So healing can be stunted if oxidative stress is either too high or too low. The third principle would be reactivating immune coordination. So cancer thrives when the tissue-resident macrophages become fatigued and stop functioning. One of their functions also regulates the healing process. And then I guess the fourth is just supplying the nutrients to kickstart optimal cellular function. So by addressing these 4 things at the local level, we're creating an environment where the body can regulate itself properly again. And one of the most effective ways to achieve that is through the IBAL-based therapies. Again, IBAL stands for Ion Biotechnology Aqueous Ligands. And at its core, it's simply a way to deliver essential ions more efficiently and effectively than ever before. So stress cells require more nutrients than the bloodstream can provide systemic. If you tried to increase the systemic levels to what would satisfy stress cells, you risk throwing off homeostasis and causing unintended side effects elsewhere in the body. IBAL solves this by allowing high local concentrations of bioavailable ions. So cells can absorb what they need, and then the excess is either used in the liver, which is after the cells expel what they don't need, it gets in the bloodstream, collects in the liver can use it, or safely excrete it from the body. And that's why I say that IBAL works locally first before having any systemic effects. And IBAL does target these kind of key terrain factors that prevent cancer cells from properly transitioning through the cell danger response. First of all, they eliminate fungal suppression. Remember, IBAL is highly antimicrobial, and it can go through and penetrate and break down biofilms, so it can actually access the cells. It can restore oxidative balance. It can reactivate immune coordination in the actual tissue, the tissue resident macrophages. So it can help bring back their function. And it supplies the available nutrients, the essential ions, that are most needed for optimal function. Now, there's all sorts of other nutrients that you need, of course, but it's supplying the ones that become real deficient in the cells when they're stressed. So really, when we apply IBAL, we're correcting or trying to correct the terrain at the source of the problem instead of attempting kind of systemic changes and hoping that they can reach the right place. So here's an analogy, right? Think of a town with a broken water pipe, and they've got this amazing new chemical that can harden after seeping into the crack and effectively fix the broken pipe. Chemotherapy or conventional medicine kind of would dump this chemical into the entire reservoir that supplies the town, hoping that some eventually reaches the affected neighborhood with the cracked pipe. But that often causes new problems elsewhere, right? So IBAL, on the other hand, or chemo, applies the chemical directly to the cracked pipes in the area, in the area with the cracked pipes, kind of restoring function exactly where it's needed, before making larger changes elsewhere. And that local first approach means you've got less collateral damage and faster recovery. But it's a completely different way of thinking about cancer. Instead of how do we kill the cancer, is chemotherapy, or how do we kill the cancer cells? Chemotherapy asks, what's preventing the cells from healing? And by addressing the real terrain issues, we create an environment where the cells will restore themselves. And
so it's really targeted in that way. Yeah.
So and targeting is kind of the biggest issue. You've got there are plenty of what could be considered salutogenic therapies, nutritional, all that kind of stuff, but the targeting is what's really, really hard.
Yeah. Okay. Now, of course, we've touched upon in previous episodes too that IBAL has shown to work across many different conditions like wound healing, infections, chronic disease, and even now cancer. But, how do you help people overcome the skepticism that comes with it? That's something that looks like so powerful, works on so many things. So how are you dealing with that? Are people believing you, what you're saying?
Yeah, I get it. It sounds unbelievable for sure. And we've kind of been conditioned to think that, no single thing could work across so many different conditions, right? But that's because conventional medicine doesn't focus on terrain restoration, focus on finding very specific dysfunctions. You could also call those symptoms, and defining that as individual diseases and then targeting them as though they're entirely separate problems. But if you step back and look at how the body works, it makes sense that restoring cellular and immune function would have broad effects. After all, same core issues, right? Immune suppression, oxidative stress, microbial interference, and nutrient deficiencies kind of involved in almost everything. Definitely every chronic condition, right? So this really isn't magic. It's just our biology working the way that it was supposed to. Another thing, it's easy to forget, but almost every major medical breakthrough was dismissed. People laughed at the idea that, these invisible microbes cause disease. Now Germ theory is common knowledge. For decades, stress was blamed for ulcers when it turned out that a bacteria, H. pylori, a bacterial infection was the real cause. Or not very long ago at all, gut bacteria were kind of seen as somewhat unimportant, which is why broad antibiotic treatments became so commonplace. Now we know that the microbiome affects everything from digestion to brain function. But each of these shifts challenged the entrenched way of thinking, and I believe the same thing is kind of happening now with the cell suppression theory. Very few people know about it, so it hasn't gotten too far into this yet. But the reason IBAL seems too good to be true is because we're used to thinking of treatments as, something that is forcing a specific action, kill this or suppress that or cause that. But IBAL doesn't really force anything. It simply removes blocks preventing normal function, clearing microbial interference, restoring oxidative balance. We've talked about all these things over and over again. But once those problems are gone, the body then can regulate itself how it was meant to. That's why it works across so many different conditions, because it's not treating symptoms, it's restoring function. I guess in truth, I encourage skepticism. I was skeptical myself at first. I used this through eudaimonia on all sorts of people for a year. I just got a bunch of the cosmetic products and gave it out to people to see what it did. Because while I had seen it have really positive effects on my family with cancer, that could have been something else. There was an N of one or two, so I was trying to collect as much data as I could. But when you see something working over and over again on wounds, infections, chronic disease, cancer, you have to start asking, is this just coincidence, or we've been looking at disease wrong the entire time? And when you really start to understand the cell danger response and terrain dysfunction, and that they can keep the body or cells trapped in this cycle of stress and compromise, you realize that IBAL simply correcting what's broken. So instead of asking, why does IBAL and CMO work for so many things, maybe the better question is, why are we so surprised that restoring cellular function can fix so much?
Yep. I
Because if
agree.
you look at it that way, it kind of makes sense.
Yeah. And a big part of IBAL's success comes from its ability to reduce oxidative stress, and in a way that's very different from the conventional antioxidants, right? So can you explain how that mechanism, what's the science behind it, how it actually works?
Yes. And I find it interesting that you're asking a science-based question here. Because I'm known to go a little bit deep on these, but actually this is a good one to choose. I guess we did kind of beat the antimicrobial to death, or the antimicrobial effects to death a while ago. We talked about the conditional antioxidant before, but that really is so. Basically, again, oxidative stress isn't just something that kills pathogens. It's also a critical signaling mechanism. It helps the cells decide when to heal, adapt, or self-terminate. And so when or if a cell's under stress, the oxidative molecules signal that it needs to either repair itself, or if the damage is too great, undergo apoptosis. But if the oxidative stress is too high for too long, it can create a CDR trigger impacting progression and healing. Conversely, if it's too low or stops too soon, the cell might miss key repair signals and remain dysfunctional. So this is actually a good question. Let me back up. So the problem with traditional antioxidants is that they blindly reduce oxidation and oxidative stress without considering whether the cell is actually ready for it or not, right? So, and if you shut down the oxidative stress too soon, the cell might not complete the necessary steps to resolve whatever the damage was, leaving it stuck in that dysfunction. And, conversely, if it's too high, we can get stuck into that kind of vicious cycle where the CDR progression can then be stunted, and then that delays healing as well. And this sort of explains why high-dose antioxidant therapies have been somewhat disappointing in clinical trials on cancer. They can reduce oxidative stress for sure, but they also interfere with the cell's ability to self-regulate its recovery, and doesn't address the terrain issue. But let's set that aside. So IBAL isn't just another antioxidant, right? So it's a conditional one, meaning it doesn't force oxidation down, but supports the cell's own ability to regulate oxidative balance. Let's see. So when a cell is ready for CDR progression, IBAL helps reduce the oxidative stress, making it easier for the cell to actually progress and move forward. If the cell needs the oxidative stress as part of an immune response or repair process, IBAL doesn't actually interfere with that. In fact, it can also even help create reactive oxygen species when necessary. And I understand that sounds like magic because it's doing two completely opposite things, but all it's doing is it's supplying the essential ions critical for cellular redox control. That's all it does. So one of the cell's first lines of defense against reactive oxygen species is that enzyme. We've talked about this before, superoxide dismutase, or SOD. So cells can produce SOD pretty rapidly, but the enzyme can't function until it binds to the ionic cofactors. The issue isn't the production, how fast the cells can produce SOD. The issue is the local availability, and the local is important here. Local availability of these essential ions activated. IBAL resolves that supply issue because it supplies the ions directly to the cells, allowing them to regulate the oxidative stress and do it as fast as they want. So I guess, and then flip that around. When cells need more reactive oxygen species to fight off pathogens or increase cellular signaling or whatever needs to happen, the essential ions that IBAL supplies can also support that function. So instead of forcing one action or the other, IBAL is just working within the body's existing redox regulation, ensuring that cellular signaling remains optimal and cells can progress naturally through the CDR phases rather than getting stuck or being forced forward before they're ready. I've got another analogy for you. Think of oxidative stress like a construction site. CDR1, the oxidative stress, is the demolition crew breaking stuff down. In CDR2, oxidative stress is kind of like a safety barrier. Just enough is needed to keep the area secure until repairs are done. And then in CDR3, oxidative stress is the cleanup crew, clearing everything out so it's not in the way. Traditional antioxidants rush in too early and start dismantling all the safety barriers and everything before the site's ready. IBAL, on the other hand, either helps from the demolition crew all the way to the cleanup crew. And that's why IBAL works where traditional antioxidants can fail. It doesn't just suppress the oxidation, but it helps the body regulate correctly.
What a great example to explain this. That was great. So you have mentioned before that IBAL's antimicrobial properties were one of its first proven successes. How did researchers make the leap from treating what they do right now, infections, to realizing its potential for cancer therapy? How does that work?
Okay, so it's not, this can be a really long story, so I'm going to try and keep it short, but that's not really how it happened. So IBAL wasn't developed as an antimicrobial. Well, not really. So sort of. It was an ancestral medicine used for infection long before microbes were even understood. And so once it was, quote unquote, discovered, and turned into IBAL, it was originally, used to clear, antimicrobial, or infections. And this was confirmed by in vitro studies showing that it could kill, pretty much everything that we tested on. But immediately after its discovery, it was actually being used on plants, expecting to see healthier, more disease-resistant plants. And they were, but they didn't just resist disease. It wasn't just killing or getting rid of bacterial and fungal infections on the plants. The plants were thriving beyond what that would explain. And that was kind of the turning point. And so something more than just antimicrobial action was occurring, right? And the assumption was that it improved mitochondrial function somehow. And then that led to its use in cosmetics, since healthy skin is beautiful. Or more beautiful. And then after it entered cosmetic products, something surprising happened. Skin not only looked healthier and prettier, but reports of skin cancers disappearing started coming in. And at the time, kind of a rudimentary understanding of the Warburg effect led to the erroneous conclusion that IBAL killed any anaerobic cells. But that wasn't entirely true, and that's not really what's happening. So as we then saw more cancer efficacy, we started testing it in vitro across multiple cancer cell types and never found one that it didn't have efficacy on. And over time, we got anecdotal reports of efficacy on many more chronic diseases. And, but sticking with cancer, the antimicrobial or the anecdotal results, and we started to notice something strange, right? So it always had to clear microbial cells first before it could start working on and having a strong effect on the cancer cells. And so let's set that aside for a second. What I saw was I got to see that it dramatically reduced oxidative stress. I saw this firsthand. Kind of two things point to that. One is I live in the mountains in Colorado, and it gets really dry. And my son used to get really severe eczema all over his back. And, these IBAL-based creams made it look like brand new baby skin in just a few days. And at the time, I didn't understand why. It was actually still the assumption that those were abnormal or that IBAL just killed abnormal cells. And I kind of scratched my head there. Is dry skin abnormal? Why is it doing this? Because it works really, really well. The other thing is kind of living at a summer camp with sand volleyball courts. At least in the summer, I spend a lot of time out in the sun, but I don't really like all of the unpronounceable chemicals in sunscreen. So that means I get way too much sun at the beginning of each season or each summer season for my white skin to handle. And, but so I used IBAL products for years to turn minor burns into a tan kind of overnight. And coincidentally, whenever I would get really burnt, it wouldn't reduce the redness as much. I originally thought that, it was just limited in how much effect it could really have. But now that makes a lot more sense, right? If I really damage the skin, the oxidative stress was warranted for a while until the repairs were sufficient. So what did we know? We knew that it was antimicrobial. We knew it could penetrate biofilm. Those were things that we got out of in vitro studies. It was dramatically reducing oxidative stress. It was somehow improving cellular signaling so that it could help ensure cells would self-terminate. Couldn't really fully explain how all of those things fit together. We knew IBAL had a powerful local effect, and it took longer to produce kind of what you would call more systemic effects. Now, we eventually developed kind of an application hack where you apply it topically to lymph nodes to kind of facilitate what would be considered more systemic effects, but it still takes longer than, say, for skin cancer, right? Which is truly very localized. And there was already research showing that zinc can renature the P53 protein to reinforce apoptotic pathways. That kind of explained what we were seeing in vitro more than some of the in vitro anti-cancer testing showed that more than 90% of the cancer-induced, the IBAL-induced cancer cell death was apoptotic. So that kind of matched. And that also matched the anecdotal evidence that we'd seen for years, right? That IBAL caused little to no scarring, even when the body was expelling tumors or something through the dermis. And I guess we also see further confirmation of this today as the severe diabetic wounds heal with minimal scarring. So by that point, we'd seen enough real world evidence of IBAL's safety and efficacy that we felt comfortable bootstrapping the pharmaceutical development. That's generally a terrible idea, and I don't recommend anybody try that, but we believed in it, so we did it. And we kind of went with a minimum viable product approach, starting with an antimicrobial for infection control and wound healing, because that would be drastically easier and cheaper than a cancer treatment. And we knew that IBAL-based products were great for wound healing. We didn't. So the results really with the ion or with ion gel ZCM25, the results really kind of blew past our expectations. We assumed that its efficacy had something to do with its ability to conditionally reduce oxidative stress, but we still struggled a little bit to explain why IBAL was working on such a wide range of issues so well until I came across Dr. Navio's cell danger response, the CDR model, and then suddenly everything made sense. And then, though we hadn't proven it at the time, we knew that cancer had a microbial component, which partially explained why the cells were trapped in CDR2. But when Mark Lintern published his book, The Cancer Resolution, detailing the cell suppression theory, everything really fell into place. Cancer wasn't just an issue of anaerobic metabolism or mutations. It was a terrain problem driven by fungal suppression and immune fatigue. So the antifungal effects weren't really, they weren't just a side benefit. They were directly influencing the CDR progression of the cells. And that changed everything. So I guess key takeaways from all of this, the ability to penetrate biofilm and local immune and the structural or the cancer cells locally to eliminate any intracellular or microbial or I guess fungal infection, while also modulating redox balance, is critical for treating cancer. And then beyond that, IBAL's impact on the mitochondrial and other cellular functions obviously also play a key role in helping the cells to be able to properly regulate and control their fate, whether that means recovery or self-termination.
And let's talk about the results here. So how does the CMO optimization, which is the cellular and microimmune optimization, which we're calling CMO or CMO, this therapy compare to chemotherapy in terms of effectiveness, side effects, and cost? Are there any side effects of this still or no? Can you talk to us about that?
Not that we've found. So I guess to put it simply, chemotherapy and conventional oncology operate under completely different philosophies, right? They're completely different. Um, so, uh, you know, chemoradiation, immunotherapy, all the cryogenic mindset of kill all cancers, kill cancer at all costs, regardless of collateral damage, right? They assume that the cancer itself was the problem. And if we can poison, burn, or manipulate the body to just enough so that the patient doesn't die, we might eliminate the cancer before it kills the patient. Chemotherapy, on the other hand, is a salutogenic approach. It assumes cancer isn't the real problem. It's a symptom of immune suppression, microbial interference, and terrain dysfunction. Instead of attacking the cancer directly, chemotherapy removes the roadblocks, preventing the body from regulating itself. So I guess break that down into a few different categories. Effectiveness, right? So conventional oncology's goal is simple. Kill cancer cells faster than the body dies. But because it's a pretty blunt instrument, it often leaves cancer cells behind, and they can come back more aggressive. Chemotherapy doesn't target the cancer cells for destruction, right? It removes the suppression, restores oxidative balance, reactivates immune coordination, and then that just lets the body handle cancer like any other biological challenge, either repairing damaged cells or eliminating them naturally. And I guess the big difference in effectiveness is the conventional treatments often weaken the body over time, while the chemotherapy strengthens it. That's why we see cases where patients following the chemo approach continue improving rather than cycling through remission and relapse. I guess you've also got side effects, right? So chemo causes systemic toxicity because it attacks all rapidly dividing cells, not just cancer. And that's why you get all of the side effects from chemotherapy. Meanwhile, chemotherapy has, the entirely different safety. It works with the body instead of against it. Most common experiences, I suppose, are local inflammation as the immune system clears out damaged cells and infections. You can also get the temporary detox reactions, such as when the biofilms are breaking down and the body needs to eliminate the microbial debris. And you can sometimes get tumors actually expelling through the dermis. And that can be a little bit unsettling to see, but it often results in kind of minimal scarring once the body's is fully repaired and resolved the issue. But again, it still comes down to conventional therapies weaken the immune system, chemotherapy supports it. And really, if chemotherapy works at all, it's because the immune system eventually recovers enough to clear out the remaining cancer cells before they reestablish themselves, right? On the other hand, the chemotherapy restores immune function from the start, allowing the body to, potentially stay stronger while it's clearing the disease. Another thing to look at is cost. Chemotherapy and immunotherapy, they're not just expensive. They're insanely expensive. A single round of chemo can cost, tens of thousands of dollars, unless it's something that's been used forever and now has less efficacy. But oftentimes, you need multiple rounds. Immunotherapy, like the checkpoint inhibitors and such, these can cost a few $100,000 annually. Chemotherapy, on the other hand, was developed with accessibility in mind, right? So for it to actually help people, we know that it has to be a fraction of the price of other conventional therapies and treatments. And if we use the ion gel pricing as a gauge, granted that's actually less expensive than the cosmetics, but and if we were to try and replicate chemo, using the ion gel, it costs, maybe $5,000 annually. And while I guess conventional treatments are or can be a recurring cost because of frequent relapses, chemotherapy allows people to shift from a higher therapeutic dose to a lower maintenance routine, to, just a few $100s a year instead of that 5,000. And so really the truth here is it's hard to know when cancer's gone. A doctor's all clear is really just a guess. But because chemotherapy is safe and non-toxic, it can be used continually at a much lower level than you would use clinically, if that's a way to put it. And because of its safety and then its minimal cost, you could just continue to use it at a much lower level. Whereas chemo is so toxic and expensive, you can't justify continued use, obviously, until the cancer comes back, which isn't terribly ideal. And I guess really, if we're looking at that for the long-term outcomes, that's probably the biggest difference, right? Conventional treatments can actually increase the likelihood of cancer stem cell production, which is why many patients see the recurrence. It's also why relapse can be harder to treat than previous bouts with cancer. Or chemo works in the opposite direction, right? It removes the microbial suppression. It supports immune coordination, and the body can regulate cancer, heal naturally. That means that instead of setting the body up for future relapses, chemotherapy is helping to create long-term health. And I don't know, when you compare the two models, the choice, at least to me, seems obvious. Do you want to poison the body and hope for the best? Or do you want to restore the conditions that keep cancer from thriving in the first?
Yeah, I think the choice is obvious. And what about the real world examples of people who have used the chemotherapy successful? Is there any I guess case study that you can point to or mention?
Sort of. Again, almost all of the cancer use, except for the in vitro studies, which to some extent aren't terribly worthwhile because they're in vitro. Everything's anecdotal to date. Now, I think the best place to start might actually be with the simple fact that the majority of IBAL-based cosmetic products are now purchased by integrative doctors. So word of mouth alone has led to many of the largest integrative cancer clinics in the U.S. and Mexico adopting IBAL products as part of their protocols. And now they can't make any medical claims, can't make any more than we can. So they treat it like any other nutritional supplement they would recommend, something that supports brain resolution rather than a direct cancer treatment. And I don't know, the reason this is important is that I guess doctors hopefully have a stronger understanding of salutogenic approaches, or at least integrative doctors have a stronger understanding than most individuals who would be purchasing, the IBAL-based cosmetics directly on their own. But we still run into some issues where even the integrative medicine world, there's still a lack of coordination when it comes to using multiple salutogenic therapies together, right? And then that brings up one of the biggest challenges we see, which is people are moving in the right direction, but they're applying these alternative salutogenic approaches in kind of a haphazard way. And it's great that more and more people are moving away from purely cratogenic treatments. So that's a good thing. But so they're adding antifungal therapies if they understand the cell suppression theory. They're adding metabolic interventions if they're understanding the metabolic theory of cancer. They're having immune supporting treatments and such, but without a clear strategy or understanding of how these interact with the cell danger response, cell suppression theory, and metabolic theory of cancer, we can kind of run into some issues, right? So, okay, so what happens, right? So people start kind of throwing everything at the wall to see what sticks. That's kind of what happens here. And you can run into a bunch of different mistakes. So using antifungal treatments, right, without understanding systemic versus local effects. A good one is honey. Honey is antimicrobial and antifungal. But not considering that it's also sugar and, not understanding that whatever are the components within honey that make it antifungal, well, after it goes through your digestive system and then gets into your body systemically, are those components, whatever they are, still going to make it to the cancer cells? We have no idea. And you have to take in a lot of sugar along with that path, and we know that that's probably not the best thing for cancer. So I guess I would argue if you're going to have sugar, okay, well then maybe switch it out for honey, but maybe better not to have the sugar in the first place. Especially early on in the cancer treatments. We talked about ivermectin, repurposed drugs or off-label drugs, and there's also bendazole. I'd even throw in, curcumin and stuff. You've taken all these in kind of isolation. Many of these do have cratogenic effects that can help in some contexts, but they could also disrupt healing if used incorrectly. And it's really hard to understand what correctly is in that case. And then even the applying extreme metabolic therapies, without timing them correctly or understanding them, fasting, keto, hyperbaric oxygen, they can all be really powerful tools. But they can slow healing or interfere with the CDR progression if used at the wrong times, or excessively, so on and so forth. And then kind of randomly combining more stress-based therapies like cold plunges or saunas. Doing a cold plunge, for example, immediately followed by a sauna, forces vascular adaptation, which can be awesome, but it also then bypasses the body's ability to recover naturally, to recover your temperature naturally. And, so without understanding the structure of what you're doing, these approaches may cancel each other out or limit benefits. And even integrative doctors who are, I guess, way ahead of the curve here compared to conventional oncologists, for sure, often struggle with this. And the reason that there hasn't really been a clear framework kind of tying all of these approaches together, hopefully until now. This is where chemotherapy hopefully makes the difference, right? Provides a structure that's been missing. Instead of saying X therapy is good or Y therapy is bad or whatever, it explains when a therapy should be used versus when to hold off, how to combine therapies effectively rather than kind of haphazardly stacking them together, how to ensure interventions support CDR progression rather than disrupting it. Instead of taking a kill cancer approach, chemotherapy is about removing roadblocks so the body can regulate itself properly, right? And it helps ensure that every intervention aligns with a natural healing process rather than overriding it. And I apologize. I think I'm going off on a tangent here. I'll kind of come back to to your actual question. What have we seen? I do want to mention one other thing so especially with IBAL use, we kind of need guidance because nobody knows what this is. And I do want to mention, so as IBAL-based products became more widely used, it became clear that people were buying them for more clinical reasons, even though they were sold as cosmetics. And of course, the cosmetic manufacturers can't make any medical claims, and most users didn't have enough information about how to use it effectively. So to help people kind of navigate these things, a free health coaching resource was created, and staffed by a group that had kind of a deeper knowledge of both kind of, conventional and alternative treatments worldwide. Also a strong understanding of how IBAL supports health in various conditions. And it was a very, I guess, patient-centered approach that didn't push any particular treatment. And so the idea was really simple, right? Help people integrate IBAL products into whatever else they were doing without judgment of what they were doing, right? So if somebody is actually choosing to do chemo, the coaches wouldn't say, oh, that's really bad. That'll kill you. They just help them understand how IBAL might be able to support their recovery even while doing chemo. Same thing if someone's choosing to do alternative treatments, the coaches can help them avoid common mistakes and pitfalls and, integrate IBAL use into it more effectively. And I guess the other thing there, I sort of am obliged to say this, as we're spread, the manufacturers also took a couple other steps to ensure that no one felt scammed or misled, because most of the time when something sounds too good to be true, it is. They offered basically a money back guarantee for any reason, right? And so the intent there was to try and eliminate the let's say somebody bought IBAL products because a friend told them, oh, it helped, get rid of my cancer. But then, later their oncologist said, what are you talking about? You're putting an antimicrobial, or actually they wouldn't even know that. You're putting a topical cream on, to get rid of breast cancer. That doesn't make any sense. They're just scamming you. Fine. They come back and say, oh, my doctor tells me that I shouldn't use this because it's a scam. Fine. They can get their money back. And in that way, help people who wanted help and, without over promising, I suppose. But so really back to your question, some of the most striking cases have come from patients who really had already exhausted both the conventional and alternative treatments. One that I might have talked about a while before, I'm not really sure. We might have talked about it offline at one point, but it was an untreatable lymphoma case. So lymphoma is actually more of a systemic cancer. So I was actually a little concerned that our local first application, or the CMO being local first, wouldn't work well. But their blood work dramatically improved after just a couple months of using it on lymph nodes. And that was actually so much so that even their conventional oncologist told them to continue doing whatever they were doing. Another one is, I guess the worst skin cancer that we've ever seen. Now, this person had been through chemotherapy, immunotherapy, black salve use, and none of it really worked. Immunotherapy apparently was working fairly well, but it also caused adrenal fatigue, and so they could no longer do it, or they had to stop. Now, that one, to get started, it was all over the back of the guy's shoulder blade up to his trapezius muscle, and even up the top a little bit. It was large. And there was a lot of tissue damage from using the black salve. And so the IBAL products had to repair that tissue, or had to supply the nutrients to allow the body to repair that tissue. And it was all moving in the right direction. Everything was actually looking really well. And I think it took about a month or two, and his blood work came back significantly better as well. So he had 3 inflammation markers that were pretty bad. 2 of them went back to within normal. 1 got back within almost normal, but at the same time, there was still a pretty large wound. So I wouldn't have expected the inflammation to go to nothing, because he still had a wound that he needed to heal. Now, that one in particular was taking a lot longer to heal than we expected. And this is part of the problem with that health coaching, we don't necessarily get all of the information. And turned out he had other cancers. So we're not really sure that this was skin cancer. It might have been a different cancer, and that's how it was now presenting itself. It had eventually, come to the surface and broken out. And so while it was moving forward, it wasn't quite as easy as most skin cancers are. Most skin cancers are treated in a week or two. And it's super fast. Now, granted, this one was really large. So even if it was a skin cancer that large, I guess I would still expect it to take a lot longer. There was all sorts of other redness and stuff. But so we've got thousands of cases that have been tracked. I assume we probably don't want to go through them all. I think I lost sound.
Can you hear me now?
There we are. Now you're back.
Yeah. Before we conclude today's conversation, so where do you go from here? Like, what's the next step in the chemotherapy, and do you see it integrated into mainstream oncology? You mentioned a little bit like how there is some adoption happening on the oncologists, especially integrative physicians using the IBAL products, but it's nowhere near it has to be. So where do you see what are the next steps from here?
Okay. So I'll be honest, we're still trying to figure this out. On one hand, we know that we can help people right now with IBAL-based cosmetic products, but topicals or a topical application and even nebulization aren't ideal delivery methods for something like breast cancer or other deep-seated tumors. That said, breast cancer is actually one of the most common internal cancers we've seen, second only to skin cancer. So, while we know that it works, we also know that we need a better delivery system or better delivery systems to optimize results for internal or systemic cancers. And I guess that leads us to the big challenge, right? Drug development is extremely expensive. While we are fully committed to keeping the IBAL products and chemotherapies affordable and accessible, and that's why we've structured the Ionic Alliance Foundation to control the patents and intellectual property. So the IAF's mission is pretty simple. It's increase awareness of Ion Biotechnology and ensure that IBAL-based chemotherapies stay accessible throughout the world. But we're also realistic. At some point, pharmaceutical development is necessary to expand access. And as naive as it makes us seem, seeing as we started bootstrapping drug development, we're not that naive. We know that at some point, IBAL-based drugs need to be developed by pharmaceutical companies that have the resources to complete the process. And this is kind of where we've sort of drawn the line. The IAF only gets involved if someone wants an exclusive license. For example, it might make sense to let a pharma company develop an injectable IBAL-based drug for breast cancer or prostate cancer or post-exposure respiratory treatment. That would probably be nebulized. But we're not going to hand over the entire technology to a company that wants total control over pricing and distribution everywhere. Instead, we want to encourage multiple companies to develop IBAL drugs and have competition, ensuring that no single company has a monopoly and that people always have options. Now, that said, again, if you want a breast cancer treatment, there will probably be one pharmaceutical company that controls that. But we also, and that's probably going to have by far the highest efficacy of any breast cancer treatment, even, or any, I guess I can't say any IBAL use for breast cancer. That's going to be the best. But we know that it kind of works even with the topical cosmetic applications. So if for whatever reason you can't afford that, you can't have access to it, your insurance won't cover it, at least there are other options. And but so I guess so we did develop sort of a stepwise plan to scale IBAL based chemotherapies. The first step was obviously the ion gel ZCM25. That was our first drug, really got classified as a medical device. And we started with the wound healing as a minimum viable product, proving that IBAL-based APIs were suitable for drug development. That was really our biggest goal. We did have, the ion gel didn't just clear infections. It also showed kind of remarkable tissue regenerative effects. But really the second step was to go immediately into skin cancer trials. So the plan was to take the same ion gel formulation and have a skin cancer trial. We already know what the results are going to be. We already know that they're going to be great. We've seen thousands of anecdotal cases, right? And that trial would allow us to kind of transition the ion gel from the medical device that it is to a cancer drug, giving it regulatory approval for at least skin cancer oncology. And then the idea was really only to take that probably to phase 2 clinical trials. That's where the drug development risk really drops off. And the hope was that we could just sell that, license it to a pharmaceutical company, let them pay the crazy amounts of money to take it the rest of the way, and then distribute it throughout the world. Then we could use the funds we got from that license to basically repeat that process and start drug development with injectable and or nebulized versions for larger things, such as now truly breast cancer. And then once we got to the point where a pharmaceutical company was interested in that, we could sell those off or license those off. And, but because even the early stage drug development is so expensive, even for skin cancer, we're going to have to focus on proving just the ion gel first before branching out into other applications. And remember, we are committed to keeping it in cosmetic products and finding more cosmetic manufacturers who want to put it into their products, to ensure that, if you can't get it into, or you can't get IBAL or can't get access to IBAL through, medical products, whatever they are, you can still get them through cosmetics, in which case then you can't make claims and such, but it's still going to at least do something. And if we're actually talking about like cancer research, I get why people want to push for more, but honestly, I'm not really interested in waiting for formal approval. We already know that chemotherapy works. We're not, or I don't want to wait years for, the research to prove what is already happening. And, so will further research make things better? Absolutely. But this is the beauty of salutogenic therapies, right? It comes down, or it comes down to they have so few negatives that there's no reason not to start using it now, even if you know that research and development is going to make it better in the future. That's fine. We've got what we've got now. We know it's good. Why can't we use it? So the goal really is to get chemotherapy to as many people as possible now. And again, on the medical front, that means that we have to kind of prioritize cost-conscious markets, places where governments and healthcare providers actually care about reducing healthcare costs rather than maximizing their revenue. So that kind of, so IBAL-based chemotherapy can dramatically reduce costs and improve outcomes, but that's a problem for revenue-focused markets such as the U.S. Many chronic diseases are billion-dollar revenue streams for hospitals and pharmaceutical companies. Let's take the diabetic wound care as an example. A diabetic or a severe diabetic wound might generate, actually take the one that we've talked about before that was on the back of someone's calf. That might cost $50,000 or more in revenue, or generate $50,000 or more in revenue. You've got hospital stays, skin grafts, hyperbaric oxygen, antibiotic use. Then when all of that fails, because they can't actually treat the underlying infection, amputation, prosthetic fitting, physical therapy, more hospital stays, so on and so forth. And remember, for that particular case, they used $150 worth of ion gel to resolve it. And they didn't even use it correctly. Proper use probably would have cut the healing time in half. So that's why we have to start with cost-conscious markets, places that prioritize effectiveness over revenue generation. But also, let's kind of back up and remember that the chemotherapy isn't just about treating cancer. It's about changing the way we approach health as a whole. Instead of fighting disease, we should restore the body's ability to regulate itself. Instead of forcing these biological responses, we should remove the blocks preventing normal function. And instead of making people dependent on a failing system, we should give them these tools to stay healthy long term. And we don't want to wait for mainstream approval to do that. Again, because this is a salutogenic approach, and because safety that comes with it, people are already using chemotherapy or IBAL-based chemotherapy, and they're already seeing results. And I guess the future is about scaling what is already working, not waiting for permission for a system that benefits from keeping people sick. And so I guess I do want to end that by saying this is a massive project that we're working on here, and we're open to input. If anyone has insight, connections, funding ideas, we want to hear from you. I've been involved for over a decade now without making any money. That's not my motivation, but realistically, we need to raise money to scale this and to help the most people. So we're willing to listen to anyone who wants to help bring this to the world.
Yeah, please reach out directly to Jasen. With every show, we also have link to the Ion Foundation's website. So if you feel like you want to reach out to him directly on LinkedIn, there's his LinkedIn link. But big undertaking, and we need all the helping hands, helping resources, what we can get. And until then, go ahead and also try the ion gel if you would, and we can get you the information too. If you want to directly reach out to us, we can also get you help you get you those things directly to you as well in the U.
So the ion gel can only be used in Mexico. There are a couple different brands of cosmetic products that are putting the IBAL formulaic base into it. I probably shouldn't actually mention those now, because I don't want to have anyone claim that I'm tying medical claims to any individual product.
Yeah, that makes sense. Sure. All right, cool. We'll conclude our episode here. Thanks again, Jasen, for sharing all the insights on specifically IBAL and again the chemotherapy that we discussed all along in this episode in much detail along with IBAL. So thanks again once again. Appreciate your insights, and we appreciate your mission. It's been a long journey. It continues to be, and hopefully we can get this into more hands. That's what we are hoping for here. Thank you.
Well, thank you very much.